Hi, I'm Paul. Welcome back to another Blazor build. Today I thought we'd do a follow-up on the last build, which was regarding an accessible pager. In that build I showed the pager being used on the weather page, manually adding a debounce filter to show how the pager works with filtered records, ensuring that screen reader users were informed of the filtering. The debounce filter made use of a system timer that on each keystroke restarted the timer, which then called a filtering function if the timer elapsed before another key was pressed. This is a standard approach and works well for both Blazor WASM and in most cases Blazor Server. However, given that the oninput event was used, which fires for every keystroke, I thought I'd best expand on this, as with Blazor Server this also means traffic going backwards and forwards over WebSockets for every keystroke. As a side note, the built-in Blazor input controls use the onChange event, not the oninput event, which means they update once the control has lost focus, at which point, in the case of Blazor Server, the information is then synchronized with the server, which is less resource intensive compared to the oninput event. If you want to use the oninput event in a way that does not impact the server, then you have to use native JavaScript to handle these events, thus stopping each keystroke being sent to the server. This component does exactly that, along with a couple of other things, but as mentioned, for the majority of use cases, using Blazor to handle the oninput event for a simple filter is perfectly fine. For those wanting to avoid JavaScript, then please watch the first few minutes of the paging demo, as you can use that code to help create a debounce filter without JavaScript. This component makes use of JavaScript. For Blazor WASM apps, it makes no real difference whether you utilize Blazor to handle the events or native JavaScript, but it may help for Blazor Server if resources are an issue. On screen are 5 instances of the debounce filter in various configurations, but before we go through these, just like the paging demo, I will start with the weather page, where I have added the component above Blazor templates weather table. Just like the paging demo, but minus the paging component, I have increased the number of weather items, this time only slightly to 20, so we can see everything on screen, as well as adding the same filtering logic that our component can make use of. This component instance is hiding the hint text and does not have validation enabled, and without the paging component has nothing that can inform the user visually or audibly of the result of the filter. Let's turn on NVDA, the free screen reader, and listen to what it sees.
Speech mode beeps. Speech mode talk. Filter weather results. Edit table updates as you type. Blank. A-O-T. T-O-H. Speech mode on demand. Speech mode off.
I tabbed to the filter and NVDA announced filter weather results. Edit table updates as you type. Blank. This told the user that the field is 4, it's editable and currently blank. I then typed hot, with the records being filtered once I had stopped typing. But unlike the pager demo, no announcements were made. Without such audible cues, a visually impaired user has no way of knowing if anything happened or if there are any rows in the table for them to read. If you are filtering results, dependent on your target audience, you may want to add an ARIA live region to inform assistive technologies of the result. Let's go back to the home page and look at the options available with the component. The first component includes hint text to advise the user of what it does and what it expects, as this component has validation enabled. Validation is achieved client-side by passing a regular expression pattern to the native JavaScript regex engine. The text entered is then validated each time the debounce timer elapses. I will tab to this component and type the word code slowly so you can see the results changing as I type, along with a success icon appearing. I will then enter a / to fail the regex validation.
Speech mode beeps. Speech mode talk. Filter customers. Edit table will update as you type. AZ0 to 9 characters only blank. C. O. D. E. / invalid characters. Filtering paused.
The screen reader first announced filter customers, edit, table will update as you type, A-Z 0-9 characters only, blank. When the validation failed, the screen reader announced invalid characters, filtering paused. Behind the scenes, the ARIA invalid attribute was also added to the input box. I will tab to the next component and then use Shift Tab to go back to the first component so you can hear what is announced.
Filter customers, edit table will update as you type blank. Filter customers, edit invalid entry table will update as you type, AZ 0-9 characters only selected code /.
This time the screen reader included in its announcements invalid entry. This was due to the invalid ARIA attribute. The second component has validation enabled, but the hint text excludes the field requirements. These requirements are only added to any failed validation announcements. I will tab to the second component, type a few characters, again ending with the / to fail the regex validation.
Filter customers, edit table will update as you type blank. C-O-D-E / AZ 0-9 characters only, filtering paused.
The screen reader announced the hint text, but on error announced to the user A-Z 0-9 characters only, filtering paused. Both the third and fourth components are not enabled for validation, with the fourth component opting to also hide the hint text. I will tab to each of these and enter a few characters.
Filter search results, edit table will update as you type blank. C-O-D-L-E / Filter results, edit all fields are searched as you type blank. O-D-E /
The screen reader announced the hint text for both, as irrespective of visibility, the hint text is always announced. Finally, the last component has validation enabled, but the regex pattern provided to JavaScript is erroneous.
Filter results, edit all fields are searched as you type. C. System error, filtering is unavailable at this time.
On typing a character, the screen reader announced system error, filtering is unavailable at this time. Unlike the other messages, this one is just hard-coded in the script, as you should be testing the regex patterns before using them. However, you can always include an additional parameter for this message if need be. That's it for the demo. Let's take a look at the home page, weather page and app.razor file before going through the code so you can comfortably build your own component from scratch or use the provided source code as a starting point. This source code is freely available on GitHub with the link to the repository in the video description below. As you can see, the home page just contains the components with its various parameters. For this demo, I opted to supply all of the parameter values, but various are optional. There really is not much of anything of interest to discuss here, so let's move on to the weather page. This time the component makes use of the optional parameters, which by default do not show the hint text or validate the entry. The hint text is still required as it's made available to assistive technologies. The only thing to note is the use of state has changed in the filter forecast method. Despite this being a handler for the onDebounce text callback, we are not using Blazor's event callback mechanism, which would automatically call state has changed. So if we want to render when the screen needs updating, we will need to call this ourselves. I purposely chose this path to negate unnecessary renders with Blazor Server. If validation was enabled and failed, you would probably not want to re-render the same data using valuable server resources for no reason. Next, the app.razor file. The only thing to note in this file is the use of the content/assembly name syntax to get access to the component's project style sheet. Now for the project structure and code. Before I continue, I should point out that this solution makes use of Sassy CSS, a CSS preprocessor. As this functionality is not provided out of the box with Visual Studio, I used a free Visual Studio extension. I will not be covering this here, but I previously made a short 4-minute video regarding this extension and getting started with it. The link to that video is in the video description below. The solution also makes use of TypeScript, so if this is new to you, please see my other short video regarding getting started with that setup. All of my videos use the same tool sets and configurations, so once you've watched one of them, you're good for any of the others. As with the majority of my videos, but more relevant for this build, I used the Blazor web app template, selecting the interactive server option using the location of global, but any interactive project type will do. After this, I then added a Razor library project called blazorbuilds.components for the Debounce filter component. You do not need a separate project. I tend to do this so you can see how all of the pieces fit together in case you wanted a component library that you could then build as a NuGet package. The code is the same regardless. I then updated the server project's references, updating each project's import.razor file when the appropriate using statements were necessary. I have added an assets folder to the web root with a CSS subfolder for our style sheet that will be output from our Sassy CSS, and another subfolder, JS, for the JavaScript, which is output from the TypeScript code. I have also added a related project folder, assets, with subfolders for the Sassy CSS and TypeScript files. The scripts folder just contains the text Debounce TypeScript file that creates a JavaScript module. It should be noted that a JavaScript module within Blazor acts like a singleton. Once loaded, it is reused with any state maintained while the app is running. On lines 1 of 2 of our TypeScript file are a couple of interfaces created for type safety and IntelliSense. The Debounce configuration interface matches an object coming from Blazor, with the Debounce text result interface matching an object for use within our component. The weak map on line 4 stores handler references and configuration information that we register using the input text element as the map's key. On line 5 is the raisDebounce interval method, which is called when the timer has elapsed, providing all functionality required by our component. Within this routine, we check if validation is enabled, and if so, whether the input text is valid, updating the ARIA live region and ARIA invalid attribute accordingly. We also use another timer to have any live region text cleared for when the user has finished their entry. We do this as we do not want a screen reader user to read text out of context with the virtual cursor. An object that satisfies the Debounce text result interface is then created and passed to our Blazor component via the .NET object reference Blazor callback ref. On line 43 is the handler for the oninput event. All this method does on each keystroke is restart the timer, providing the method to call if the timer elapses before the user presses another key. The register text Debounce function is the method that our component calls to have an event handler added to start the timer process. I call the unregistered text Debounce to ensure that this is not done twice in the event of any problems. The handler is added to our map along with the configuration data that we access within the raisDebounce interval method using the input element as the map's key. We then assign the handler for the input event. The unregistered text Debounce method removes any handler and weak map entry, which is called from the register method and directly from within Blazor when the component is being disposed. Finally, we export just the register and unregister methods that can be imported for public use. Next up, the SCSS folder containing 3 Sassy CSS partial files denoted by the leading underscore and the main SCSS file containing what needs to be output. The root partial file just contains a few global CSS variables. I have used global variables as these are used in my other components. A change to one of these variables updates all of the components that use them, aka theming. The SVG icons partial file is for any classes containing SVG data for icons. In this instance, and something that I have started using for state-related information, is the use of the Sassy CSS placeholders and the corresponding extend directive. In plain English, and as we will see in the next file, these blocks are like snippets that can be included within other classes. So whenever I want to show an invalid icon due to some state, like an invalid entry, I can extend an existing class when an attribute value changes, such as aria invalid. Next, the text-debounce partial file that contains the majority of the CSS for our component. On line 1, we add the use directive so we can use the placeholders added in the SVG icons partial file. I use the B.E.M block element modifier naming convention for CSS, and the text-debounce selector forms the block part of this. Most of the selectors with the double underscores are my B.E.M elements, with a single modifier class denoted by a double dash currently off screen. For those not familiar with Sassy CSS, the ampersands are not the same as the ampersand used in native CSS nesting. These ampersands denote the parent selector, and the preprocessor concatenates the text after the ampersand with the parent selector to form the new selector. For example, ampersand double underscore label when output will form one of our B.E.M elements that has the class name of text-debounce double underscore label. On line 4 is another CSS variable, but it has an underscore after the double dash in its name. This is to distinguish it from global variables, as this variable is meant for local use only. I am only going to highlight a couple of points in the CSS, as this video is not about the design, which you can alter to suit. For this component, I just used a CSS grid for the overall layout, and the only point that may be of interest is with the use of the Sassy CSS extend directive on lines 51 and 59. As briefly mentioned, this uses the CSS from the SVG icon file to create a selector that updates an existing selector. In this instance, when the aria invalid attribute is found on the input and its value is true, then the existing state icon class will be updated effectively to include the invalid icon, and when the attribute is false, will be updated to include the valid icon. I find this an extremely useful technique. On line 88 is the only B.E.M modifier class needed for this build. This is added to the markup classes when the hint text is to be hidden. This modifier is nested within its parent, the ampersand -- hidden, when output will become the class selector named text-debounce double underscore hint -text -- hidden. The media query at the end and the use of the force color adjust property makes things a little more visible if the user has set their OS to use the high contrast modes. The next file is the main SCSS file, and this just contains use directives to tell the preprocessor what to include in its output. We then have my usual common folder with 4 subfolders: enums, extensions, models and seeds. The utility extension static class just contains a single Boolean extension method that just allows me to create neat one-line statements. If you have seen any of my other videos, you know I use these quite a lot, but for this component only one method was needed. The all models file is where I would put all simple models, but for this component only one was needed. I named it Debounce text results. This object is used to hold the text value of the input obtained after each elapsed timer interval, as well as to contain any validation information. This data is passed from JavaScript to our component. The enums file only contains a single enum, style as, which is something I use for my theming scheme, and is something that I now add to all of my components. We then have a global values class that contains mainly string constants used by the component and a single static helper method for my styling scheme. There isn't anything of interest in this file. I included a default regex pattern for validation in case one was not supplied. Next up is the text debounce folder, which houses our component. As there wasn't much markup or code, I kept the single razor file instead of splitting it into markup and code files. As I have mentioned before in other videos, I find it simpler just to keep the single razor file for small components. The markup starts with a div that just acts as a container for our component. The data-static attribute is just for my theming scheme. The span is important. It's visually hidden using a screen reader only class and has the role attribute with the value of status. This is the equivalent of having the aria-live attribute with the value of polite. This creates the live region where the JavaScript will add any invalid text messages for the screen reader to announce. I like to ensure that each live region gets a unique ID, as you could have other live regions on the same page. After the span is the label for the text box. The input uses the @ref directive to capture an element reference that we can pass directly to JavaScript to negate passing an ID and then doing a DOM lookup. We also use the aria-describedBy attribute, giving it the ID of the element that houses the text that a screen reader can announce when focus is received. The describedBy attribute can reference elements that are both visible or hidden using styles such as display none, which is perfect for our needs as we have the option to hide this, and we can use display none to reclaim the space. As we have used a CSS grid with the value of auto for the column housing the icon, if we do not include the element, this space can also be reclaimed by the input. We only include the span for the icon when the validate entry is set to true. Last, we have the paragraph tag that is the container for the span that holds the hint text. This paragraph's top border forms the underline for the text box and icon. The span for the hint text is only shown if the showHint parameter value is true. If false, the getHintText classes method will include the hidden class modifier. Next, the actual code. The first two parameters also include the editor required attribute to warn the user that these two values are required. The other parameters have default values if not supplied. All of these parameters are pretty much self-explanatory. Line 34 is of interest, as instead of using an event callback to inform the parent component of the result coming back from JavaScript, we instead used a func. As previously mentioned, this was done to prevent the automatic render in the parent component that would occur if an event callback had been used. Line 36 is the element reference for the input element captured by the @ref directive in the markup. Line 37 is a private field to hold a reference to our JavaScript module. Line 38 is the .NET object reference that gets passed to JavaScript along with a method name in order for JavaScript to call us back with the result of the debounce text. Lines 40 through 45 are just fields to hold values used by the markup and/or passed to JavaScript. For this component, we use the onInitialize method that occurs just once to get the values that we need, instead of using the onParametersSet method that can be used to get updated parameter values. An exception is thrown if the user ignored the editor required attribute, as these values are needed. We then assign the parameter values to our fields or use the default values if these were not supplied. As the component can be used by either WebAssembly or server, we use the onAfterRenderAsync method to wire up the JavaScript, as it's only at this point that the DOM is available for Blazor Server to use. If it's the first render, we then call our registerTextDebounce method. This method creates the .NET object reference and builds an anonymous object containing all of the configuration information required by JavaScript, with this object matching the TypeScript interface that was created. The JS runtime is used to get a reference to our JavaScript module, which we then use to call the register function, passing it the input text element reference and the configuration data. The handle JS Debounce method, called by JavaScript, just invokes the onDebounce text func to notify the parent component of the result just received. The getHintText classes method is just a helper that is called from the markup to get either the hint class or both the hint class and the modifying class if the hint text is to be hidden. Finally, we have the dispose method, which we call JavaScript to have the handler unregistered before disposing of our references. And with that, we are done. As with all of my videos, please feel free to leave good or bad comments, and I will do my best to answer any questions raised. The links to the source code and other projects mentioned within this video are all in the video description below. Thanks for watching, and until next time, bye for now.